Let's take a look at exercise 8 from section 2.2. Here we want to find the domain and range of the relation. So we have a graph of a relation and we want to find the domain and range. So in order to do that, when I find the domain, I'm traveling along the x-axis. And I am in the domain when there's a point on the graph above me or below me or on the axis with me. And notice that does not happen until I get to x equal to 1. And then there are points above me and below me that belong to the graph. When I go to the right of 1, the graph is above me, below me, at one point even on the axis with me, until I get to x equal to 3. Now as soon as I move to the right of 3, there is no longer a point on the graph in any one of those three positions. No point is above me, below me, or on the axis with me. And so notice then the domain lies between 1 and 3, including 1 and 3. And so notice there are 2 points above me when I'm at 1, 1 point below me. Notice if I'm between 1 and 3, there's a point on the graph either above me, below me, or on the axis with me. Sometimes I fulfill more than one of those. But when I move to the right of 3, there's no graph above me, below me, or on the axis with me. So the shaded region of the x-axis is my domain. So the domain tells me about x values, not about y, so I skip A and I go to B. And the domain is the set of all x such that x is bigger than or equal to 1 and smaller than or equal to 3. And so I'm going to show you the part that you'll be filling in. So I'll put that in red, what you're going to be filling in. The black will already be given to you in my math lab. But on my math lab exercise, you'll be filling in what I've written in red. Let's give this as an interval. We include the 1 and 3 by using the square brackets. And everything in between 1 and 3, including 1 and 3. That's what this interval signifies. So this is the domain as an interval. Now let's find the range. The range talks about y values. So as I travel along the y-axis, I am in the range if the graph is to my left, right, or on the axis with me. And actually this graph should have an arrow on each end. So on these problems, if you don't see a specified point, then assume that there's an arrow. And I'm having a hard time drawing a nice arrow on here. But specified point, like these red ones here that are singled out, actually are endpoints of an interval. If you don't see a solid circle point, then you should assume arrows or either an open circle. All right, so notice for all y's in the negative direction and in the positive direction, all possible y values are achieved by this graph. So no matter what y I pick out of the set of real numbers, there's going to be a point on this graph, as long as I extend it far enough, that has that y as its y coordinate. So notice that I'm looking at these instructions and it's telling me not to use the infinity symbol. So I wouldn't choose B then, because I don't want to use, the only way I could write that using set notation is use the infinity symbol. So I choose C. The set of all real numbers is my range. And then if I want to write that as an interval, that's the interval from negative infinity to positive infinity. You never use square brackets with the infinity symbol, always the parenthesis.